Okay, so n is 1/3, right? So this becomes y to the what power? 2/3. Good. Okay, now you have to be able to write down the new differential equation. You don't need to rederive it. I derived it for you back in January one time, and I'm not expecting you to have that fresh on your mind, but I do want you to know how to convert this into the simplified, what becomes a linear equation. U prime. Alright, I'm hearing a lot of the right things out there. That's the right formula. Now just be careful, the p of x has to include minus signs. Okay, so if this is subtracted, and I'm telling you, if you make a sign error, I mean, I could say, yeah, well, I would only take off a point for a sign error. That might be fine, but if you end up then having to put that in and your integrating factor is all totally screwed up because of it, you're going to have a big problem, right? I mean, I'm going to write the test to be very reasonable, assuming it's being solved correctly. But if you get off track and you're solving a problem that you're not supposed to be solving, it's going to be a problem. So please be careful. Minus signs, fractions, everything. So here in this case, we have u prime. 1 minus n is 2/3 of the p of x, which is -3/2x times u, equals, let's see, 2/3 of 6 is actually just 4. So it becomes 4, and then the q of x is x squared ln of x. So this is the new problem. And I can simplify the coefficient of the u here. This is just u prime minus 1/x times u is equal to 4x ln x squared ln of x.
I like that.
So that brings it down to something very reasonable. Yeah. Okay. So it has become linear. And to do a linear differential equation, to solve a linear differential equation, we have to use integrating factors. So does everybody know the formula? I probably should, that should be on your note card under your pillow at night as well. I keep forgetting to couple of formulas.
Sleep with my pillow so high up.
Yeah, it's gonna hurt your neck, and you're gonna be not well rested
Yes.
from the
I don't
test.
think that's very orthodox.
I
just made a blanket of.
You could shift them out.
I'm sorry.
Shift them out for a couple of hours in the night.
I was waiting for my opportunity.
Okay, so let's do this. This becomes e to the integral of -1/x dx. Alright?
Can you take the negative out?
Now we'll pull the negative out, so this is e to the negative integral of 1/x dx. What's the integral of 1/x dx? ln of x. Good. Do we need plus c? Nope. And do we cancel the e and the ln immediately? Not until we pull that up as an exponent. Very good. So 1/x. Alright, pretty easy. So then what we end up with, and this is something else you sort of need to remember, hopefully you've done enough of them during the last few months to have it straight. Whatever that integrating factor turned out to be, times your unknown function has a product rule derivative equal to the right-hand side, which was 4x squared ln x, and then that has to be multiplied by the integrating factor, so divide by x then. In other words, 4x ln of x. And this actually is bringing up why somebody had asked me, because that particular integral is slightly harder than just what's on that basic integral table, but it is on the integral table that you'll see on that sample final. So it's so you have to integrate this by parts. Do I even know what it is?
U is ln of x or du.
You let u equal ln of x, and dv is just x. I guess I'll just rederive it. You guys don't need to worry about what I'm doing here. 1/2 x squared ln of x. Oh, there's a 4 in front of everything. And then minus the integral of v du. That's going to be 1/4 x. Okay. And this time time you do need plus c. Okay, so I just did it using integration by parts really quickly. Pardon? Just take my word for it. That's not the important part, really. Okay, so this, I'm going to simplify this. This is 2x squared ln x minus x plus this 4c. I can replace that with c1. It's like a new constant. So 1 over x times u. So this is where we're at. Incidentally, a lot of people, when they add that plus c on the right-hand side of things, they tend to think that, well, there's always a plus c on the end of everything below it. But that's not necessarily true. Once I multiply this x across, it will no longer have a plus c on the end of it. It'll be a plus c times x. And there's nothing wrong with that. That's absolutely fine. So u is equal to 2x cubed ln of x minus x squared plus c1x. Yeah, fine.
On midterm 1, on
Yeah.
the last differential equation, on the 4 that you gave us, the last one, it ended up solving, and it was like 2 terms of y on the left side, and you said, okay, that's good enough.
That was an implicit solution, probably.
Yeah.
That's because in some cases it's very difficult to actually explicitly get y by itself. And if that's the case, I would tend to only ask you for an implicit solution. I would need to be clear with you in the instructions about that. If I didn't want you to worry about trying to solve for y, I would say something like, you may leave your answer in implicit form or something along those lines. So look for those words. Explicit means you solved for y. Implicit means you didn't necessarily solve for y. Yeah, it depends. Sometimes the problems are too hard to solve for y explicitly. Okay, so this is u, so is this my final answer?
No, you're back into y.
Right, and if you wrote this down at the beginning, then see everything's so much nicer because you've got it right here. What you are going to need to do to this equation, though, is raise both sides to the 3/2 power in order to get y by itself. So y is going to be u to the 3/2, and so it just means this whole thing we just worked out is going to get raised to the 3/2 power. So it's something like this. That should be the final answer. Seem okay? Okay, so we got that. What do I want to do here? We'll do number 12. I'm not going to do number 11 because I just did it last weekend at the review session for the third test. I've done 2, 4, 5, 6, 7, 9, and 12, and I'm not going to do 11. So the only ones left are 10, 8, 1, and 3.
Yeah.
Which it doesn't do.
We did 3 like indirectly.
Oh, we did 3. Yeah, that's right, we did 3. So really it's just 1, 8, and 10. Do people need to see another example of the what we just covered, the 7.6 that we just did on Wednesday? You turned the homework in on Friday. Those 2 problems. Yeah, that's what the first problem is. I can do it, or if you know how to do it, I won't do it. Or you can study it on your own. It will take a while to do it now. Actually, it's just a long process. The thing with those problems in 7.6, I probably am going to ask you one of those, by the way. I'm not being secretive about it. It's because I've never asked you about it before, and it ties together a lot of the material. The thing about it is, it's not conceptually tricky. You just have to make sure you don't get lost in where you're at in the process. So break it into the 3 steps. The complementary function, right? Then, to get the particular solution, you need to know what is the equation for it. I think I wrote this down earlier. You know, you need the fundamental matrix times u, and you need to know how to get u. But basically, you want to pick these things off one step at a time. Write down what capital X is. Then find the inverse of it. Then multiply it by b. Then integrate it. Then take capital X times what you got. Then you have the particular solution. But you You just have to, the biggest thing, I'm gonna tell you, I have asked a question from 7.6 almost every single semester I teach this class, and there are a lot of people in the class, for whatever reason, they just choose to leave that problem blank. And I don't know why, it's like it's maybe because it's long, but it should be pretty easy points if you know the process. Right? Questions?
Can we expect to integrate integration by parts on one you give us for that? That's what I'm looking for.
Yeah, I think integration by parts also comes up on this one. A very simple integration by parts, maybe, but I can't say for sure. Yeah, it won't be anything ugly, I promise. Okay. Let's go ahead. Let's just go ahead and do number 10 while we're on the topic of differential equations here. Yeah, this is kind of reviewing some stuff from recently, a little bit. Maybe I don't want to do too much of that. But number 10, I think I can handle. I said I was going to go to Nullity. 9 o'clock. Here we are. Of course, I started late, right? 20 minutes late. Yeah, but I've got tons of time. Okay, so y double prime plus 9y equals 18 secant cubed of 3x. Oh boy, I see a nasty integral in my future. Hopefully not. Okay, well, we'll see how bad it gets. Okay, so looking at it right away, what do you know?
I can't deny it.
Very important that you know which method to use. It is a second order equation. It is not homogeneous. It's not a system. So it's got to be in chapter 6. And so it either has to be an annihilator problem or it has to be a variation of parameters problem. Right, we don't know how to annihilate a secant, let alone a secant cubed function. So let's try variation of parameters. Okay? To do variation of parameters, this looks very similar to one that was on the test.
Yeah.
Is it the same problem? It's not quite the same. Well, I know this part's the same, and I can tell you, you want to know how many people wrote r squared plus 9r on the exam? Don't do that, guys. It is y to the no derivatives power. So the characteristic equation is r squared plus 9. If I want r squared plus 9r, it would have had a prime right here. Okay. So it doesn't have that. So it's just this. What are my roots? 3i, good. So we get the complementary function straight away. What's it going to be?
C1's cosine of 3x.
Okay.
Plus C2 sine of 3x.
Great. C1 cosine 3x plus C2 sine 3x. And so we have, and this particular method, we need to kind of keep track of our solutions. So I'm going to call cosine of 3x y1, and sine of 3x, I'll call that y2. Okay? Does everybody remember the variation of parameters formulas? U1 is
Negative integral y2 f over y1.
good, and U2?
y1 f over y1.
Perfect. All right, you guys have it. So we need to, I always like to do the Wronskian next. Okay, so the Wronskian is the determinant of, I'm going to differentiate cosine of 3x and sine of 3x. So many of you did this just last week, so I'll do it quickly. Negative 3 sine of 3x on the bottom here, and 3 cosine of 3x here leaves me with a determinant of 3, because cosine squared of anything plus sine squared of anything always adds up to 1. You factored the 3 out, and that's the only thing that survives. Okay? So my denominators are going to be 3, my Wronskians. All right. So then the next thing is just setting up those integrals, right? So maybe we don't need to work this thing all the way through, because I basically wanted to make sure everybody knows those U1, U2 formulas, and that this is variation of parameters. Oh, I guess the other thing I want to make sure everybody knows is that you have to remember how to write down the particular solution. It's u1 times y1 plus u2 times y2. There is, okay, and some people on the test last week, they put a capital A and a capital B in there. And that is for the annihilator method. You don't use that here. So you just leave it literally as is. Okay, so let's see. People want me to keep going? Yeah. Not necessarily?
Yeah.
We're good. It's mostly just integration from here, and it's in the review packet. I think I'll skip continuing that one. I don't need to go through all these parts to total completion. I'm just trying to put things back in your head, what you need to review. And I know people are getting a little tired because we've been doing this for a while, so I'm going to try and hit to the highlights. Oh, here's one I want to go over. Haha. Yeah, I forgot about this one. I'm going to go to number 8, D. True or false? True. Oh, I'm not going to give you true or false on the test. I didn't do that on the midterms either, so I won't do that here. But let's treat it as true or false for right now. If A is 7 by 9 with a nullity of A equal to 2, then the row space of A is equal to R7. Yeah, we've talked about this one quite a bit.
Yeah, too much. It was on the group work.
Yeah, it's on, again, reviewing the group work, so we'll run across this.
And in the notes.
So when you see this sort of preamble, 7 by 9 matrix with the nullity of 2, what kind of comes to your mind first? Yeah, what is the rank? We know that the nullity and the rank are related, right? In fact, there's a formula. It's a good thing I mentioned it because it's been 3 hours and I haven't said the rank nullity theorem yet, right? We looked at the general version of it for linear transformations, but the sort of matrix version of the rank nullity theorem says what? Can somebody remind me? The rank plus the nullity is the number of columns, which is which of these two numbers, by the way? 9, right. So the rank of A plus the nullity of A equals the number of columns. Okay, so in this case the number of columns is 9, the nullity is 2, so the rank of A is what? Okay. The rank is 7. So the question is, true or false, row space of A equals R7? Yeah, what the rank is telling you guys, here's the thing that's important. What the rank is telling you, it's telling you the dimension of the row space.
But isn't the row space of A, R, and N?
The row space is a subspace of Rn. Good point, Aaron. So if I think about this matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9 entries, right? And I have 7 of those rows. So if you need to, you can go ahead and just kind of draw yourself a little schematic of it. But the point is the rows of the matrix, they have 9 slots to them. So they couldn't possibly form R7 because R7 only has 7 slots. So this is a false statement. What we can say, here, if we want to say something that is true, the thing that we could say that would be true is that the row space of A is a 7-dimensional subspace of R9. That would be legitimate. Okay, so this implies, right here, the rank of A is 7, tells me that the row space of A is equal to a 7-dimensional subspace of R9. There's that section in the book about row space, column space, and null space. Do you guys know how to find those 3 spaces? If I give you a specific matrix, like a specific 7 by 9 matrix, do you know how to find a basis for the row space, the column space, and the null space?
So you find this and then the corresponding rows or columns of the original matrix.
So, for all 3 of those spaces, the trick is to row reduce the matrix and circle the pivots. And then as Zach said, the pivoted rows of the row echelon form, those become the bases for the row space. Very simple. Those same pivots are also sitting in certain columns. Now, the basis for the column space doesn't come from those exact pivoted columns. If you remember, you have to take whichever columns those were and go back to the original matrix and pick off the same columns that are in the original matrix that correspond to those pivots. That'll give you a basis for the column space, right?